Good morning to all. Is it clear now? Is it clear or not? Just tell me, is it clear or not? Live chat will be there now. The live chat will check. Okay? So next topic is criteria for equilibrium and spontaneity. Okay? Entropy, change, entropy change as criterion for entropy change as criterion for spontaneity and equilibrium. And equilibrium. Okay. Actually, entropy we have to denote it by S, right? So here we have to, if you see here delta, if delta S is equal to 0, this is said to be reversible process. Okay, this is said to be reversible process. This is said to be reversible process. If delta S is greater than 0, then it is called as irreversible process. Okay, irreversible process. So here, if delta S is equal to 0, it is called as reversible process. If delta S is greater than 0, is called as irreversible process. Actually, yesterday I have explained you about what about this delta S system plus delta S surroundings are greater than 0. Is it or not? Okay. So then we can write system is equal to here ds and here delta S surroundings is equal to minus dq reversible by t. Okay. So then we have to replace this term from dq reversible is equal to, we can write du plus pdv. Okay, du plus pdv. Okay, so next, so what about here? Here, this is a tds minus dq reversible. We can write this is a tds and dq reversible by t is greater than 0. Okay, greater than 0. So if you shift this term into that, so what will get? TDS minus DQ, okay, reversible greater than or equal to 0. Here, this is a equation 1. This is equation 1. Okay. So next, Actually what we have here, dq reversible is equal to du plus pdv. Okay, so write down this one, dq reversible is equal to du plus pdv. Okay, this is the equation 2. Okay, so now you have to substitute put this equation in this one, equation 1. Okay, let's write down this. If you complete means just message me completed. Then I'll start. I'll complete అని చెప్పండి అమ్మ, నెక్స్ట్ వెళ్ళిపోతాను. ఓకే, up to here you have to note this one. Okay, is it completed? All of you? Okay, so I want to remove this. Okay. So, put equation 2 or substitution equation 2 in 1. You can write anyone. Okay. So actually what we have in equation 1, TDS minus dq reversible, right? Reversible is greater than or equal to 0. So we have to replace this term by du plus pdv. Okay. So here TDS minus of what is this one, du plus pdv. Is it or not? Okay. So greater than or equal to 0. Then what you get here, minus into plus, minus du minus pdv greater than or equal to 0. Okay. So at constant, so u and v, what becomes here, du becomes 0 and dv also becomes 0. Okay, at constant u and v, du becomes 0 and dv becomes also 0. So at that time, so this becomes 0 and this also becomes 0. So then what you get here, TDS is greater than or equal to 0. Okay. So if ds is greater than or equal to 0, for finite change, delta s is greater than or equal to 0. Okay. So and another confirmation would be there. If delta s is equal to 0, what is that process? Delta s is equal to 0. This is a reversible process. Is it or not? Reversible process. If delta s is greater than to 0, so then it is called as irreversible process. Okay, irreversible process. This is called as equilibrium process. And this is called as spontaneous process. Okay, this is the irreversible is the spontaneous process. And what about this? Reversible process is also called as, this is called as equilibrium process. Okay, reversible process is called as spontaneous process. Okay, so just note down. Is it completed, ma? ఒకరికి క్లారిటీ లేదా అందరికి క్లారిటీ లేదా ఒకరికి క్లారిటీ లేకపోతే సిగ్నల్ ప్రాబ్లం మీకు ఉంటుందమ్మా అందరికి కనిపించట్లేదా చెప్పండి ఓకే సిగ్నల్ ఫ్లక్చుయేషన్స్ will be there it will set right okay completed okay amma signal auto to fluctuate avutuntadi okay I want to continue the class okay anta kanipichakunda em ledhu kada somewhat it will be better right what about others only one or two members for one or two members it is not clear right what about others అందరికి ఎలా ఉంది చెప్పండి అందరికి అలాగే కనిపిస్తుందా ఓకే సో నెక్స్ట్ థర్డ్ లా ఆఫ్ థర్మోడైనమిక్స్ third law of thermodynamics okay third law of thermodynamics actually if you take a means entropy of a perfect pure crystalline solid if you take a perfect pure crystalline solid so it can be takes as zero it will give entropy as a zero with zero at absolute temperature zero temperature okay so at absolute zero temperature if you take a pure crystalline compound okay pure crystalline compound yes the entropy will be zero for that one okay for that entropy will be zero for a perfect pure crystalline compound okay so write down first point is the entropy of a perfect gas the entropy of a perfect gas perfect pure crystalline solid perfect pure crystalline solid because arrangement is very close to each other so there is we cannot find disorderness of the molecules so that's why we have to set so it is said to be entropy is zero at absolute zero temperature okay at absolute zero temperature okay because molecules are closely arranged in the pure crystalline compound solid it takes solid okay So that's why, so the entropy of a pure crystalline solid can be takes as zero at absolute zero temperature. At absolute zero temperature. At absolute zero temperature. So that is, so we have to write limit T to 0, delta S is equal to 0. Okay, delta S is equal to 0 for a perfect pure crystalline solid. Perfect pure crystalline solid. Okay, here why we are using this the third law of the thermodynamics means the absolute entropies of solids, whereas in case of liquids and gases also because they exist in randomness in the arrangement, right, in the arrangement of atoms of the molecules. So that's why we have to calculate the disorderedness or randomness of the particular compound, either gases or liquids or solids. Okay, mostly solids will have low entropy because the disorderness is very low in the case of solids. But if you take liquids and gases, there is a more means disorderness or randomness is increases from solid to liquids to these gases. Okay, so third law of thermodynamics thermodynamics third law of thermodynamics is used to calculate, to take, if you pour and this is solid one. Okay, so in solid all atoms are arranged close to each other, right? So that's why there may be less disorderness will be there. So that's why, so the entropy will be very low in the case of solids. But if you take liquids, so what will happen here? So disorderness or randomness of molecules are arranged in here very closely, right, in the solids, but in liquids like this. Okay, in gases state like this. So if you observe here, low randomness is there in the case of solids. Okay, but what about liquids? Here somewhat randomness increases. And what about this? Here randomness again increases in the case of gases. In the case of gases. Signal problem undamma.